Hey everyone, it's Mark Sargent from Strange World, broadcasting live every Tuesday evening, 10 to 12 Eastern, 7 to 9 Pacific, right here on True Frequency Radio. Strange World covers a wide range of topics, from enclosed world theory to lunar waves to the end of the world in film. It's basically doomsday with a silver lining. With the audience as my co-host, we take an optimistic approach to all things conspiracy and promote confidence, hope, and humor whenever possible. If there's a topic you want us to cover or a guest you would like to see interviewed, please email me at msargent23@comcast.net. So please join me and tell your friends about Truth Frequency Radio, the leader in real radio programming, bringing you quality, cutting-edge broadcasts from around the world.
We are TFR.
My faith in destiny is all I need to prevail.
Truth Frequency Radio.
Welcome back. You're listening to Jeranism Monday Night Raw. We're here with Cathexis. We just got off the phone with Nase, who had a good point and was talking about driving on Highway 70 as you approach Colorado and the appearance of mountains appearing from the top down rather than the whole thing at once. And I hear this issue a lot, and the best way I can describe it. And I just pulled up a video. Cathexis, did you get my message or no? I don't know if you saw it.
Oh, no. Let me go check it real quick.
Oh, no, I sent you this video of somebody who taped a time-lapse from driving towards Colorado. And it's absolutely incredible to see what a difference it makes when basically the person is driving just on the freeway. But when they're heading uphill on the freeway or downhill on the freeway, how the mountains will almost unfold themselves right in front of your eyes. Meaning they'll dip down behind the horizon, then they'll come all the way back up. And, it's a crazy look. But one of the things that, I think people fail to realize is that with distance, you're going to lose things because, number one, they're going away from you. Number two, they get smaller. So when you're talking about even the biggest mountain range that there is, that at a certain distance away from you, that would be a pinpoint. It would be, as big as a spitwad or whatever you want to call it. It's going to be so tiny because that's how things work. Think of a car driving away from you. At about 200 yards, you're not going to see the car any longer because it's gotten so small. So when people say, well, you should be able to see across, the Atlantic Ocean from New Jersey. Well, no, you would never see that because everything, including London, including every country over there, Spain, you name it, has all reduced in size to the size of a pinhead. And that's one of the hardest things to wrap your head around, but really that's what I think is happening. And then when you look at things that are taller, that one car that disappears at 200 yards, if you were to stack cars on top of it many times over, let's say there's 50 or 100 cars stacked, well, you're going to lose the highest one last, because that's going to be the one you can see the longest. It also is being seen through the least amount of atmospheric conditions, the least amount of smog and fog and mist and dust and smoke. And
that's mainly at 15 feet mark. I mean, most refraction happens at that level. And when dealing with the mountains, you're dealing with a ridiculous amount of local parallax, so to speak. Like, let's say you begin to see it 80 miles away. Well, if you go over a little hill, like you said, like I'm looking at the video now, and any little hill he goes over or down, it makes it dramatically move. Sometimes you can see the tip, sometimes you can see more of the bottom of it. And I think the atmosphere has way more to do with the situation than what I think most people have been getting credit for. I actually did a couple shows on my channel a couple of months ago about this atmospheric conditions, and then dealing with on land, you've got terrain, topography, and your angle of attack, like the angle at which you are seeing that object on the horizon. If you're tilted up a little or if you're tilted down a little, it's going to dramatically change the parallax of it and what you're able to see past your convergence point. Because after I just mentioned, we can only see, well, say technically 10 miles away. Like if we got a straight shot, our eyes have this convergence point that happens at about that time frame. We can only see so far, but there's still much further things past it. So it looks like an obstruction. It looks like it's being obstructed. And if you look at the ones with the water, though, like over bodies of water, are hard. Like you've seen the time lapse of the Nowicki, right? So there are times when it swells. I mean, the atmospheric conditions and the swells and waves make it look like the whole city's been taken up. But within that same time lapse, you get that beautiful shot of all the way down to the bottom level. Right. So I think the atmosphere is that. I don't want to say mysterious, but I mean, we understand the effects of it. It's just a lot of people aren't talking about it in this way, I found. It has more to do. It's
not a constant, and anything that's not a constant creates an issue scientifically because your variable is so drastically varying. Sorry for my lack of vocabulary there. But yeah, I totally agree that it is atmospherics, and that's why this test that I want to do is going to be where that is minimized. I did my first test over the ocean, and we kind of learned the hard way that that's not the best way to go about it. There is such a drastic change, even if you're 4 miles apart. The difference in the temperature and it can be a lot, even in Monterey where it's usually pretty cold. But let's go back to the phones. Got some people waiting. So we got the next caller, I believe, from California. You're on. Who's this? Where are you from?
Yeah. It's real easy to prove. I mean, really easy to prove that the Earth is flat and center of the universe. And that is, all you have to do is take a camera with time-lapse photography anywhere on the Earth, especially in the wintertime at the North Pole and the wintertime at South Pole, when you have the longest night time, and you leave the camera, open, and take the picture all night long, and Polaris will be in the center of the picture all night long. It will not move, and you can do that all year long, and you can do it from anywhere on the planet. And that would not be possible if the Earth wasn't flat and the center of the universe.
Yeah, the star trails, they're definitely, a lot of people see them differently as some level of proof or whatnot. And I believe that you can't see Polaris past, I've heard as far as about 20 degrees south. That's
because the Earth is dish-shaped. Around the equator, it's a lower altitude than it is at the 32nd parallel. And if you look at a satellite map, a pressure map, and you see the pressure gauges, and you look all the way around the world, the pressure gauges aren't from the heat of the atmosphere, it's from the weight of the atmosphere.
Mm-hmm.
Wow, that's something I'll definitely check into, because I wonder if anybody's laid that barometric pressure map on a flat Earth map, flipped it in. I'd like to do that.
Yeah. And if you do, you'll notice the reason that you can't see Polaris in certain spots is because you're below the elliptic of that dip end in the year.
So so what you're saying is that you think that the equator is, did you say it was lower or higher elevation?
Well, as you go from the North Pole to the South Pole, when you get to about the 30th parallel, you start to go downhill, so to speak.
Oh, okay.
And then you start to come back up somewhere around Australia or so. Or
like the hubcap. Yeah, kind of like the hubcap model.
Mm-hmm.
There's a couple images of that. Yeah. I think the Ferguson map.
Yep.
Okay, well, we appreciate
that's the one.
Appreciate it.